This is the main transmitter vhdl code. The first block is the vhdl standard libraries. Next, the transmitter port including dout, RTS, port clock, reset, stop, TS bit, send OK. Next, the signal. We'll discuss that later. The parity generator component and its mapping. This subcircuit takes our input data and generates a parity bit which will be used for error detection at the receiver. If this parity bit is not the same with the parity bit generated at the receiver will generate the error signal and it will come on after receiving the bit. Next are the data register in and data register 1. They are used to store received data. TS bit is a transmitted bit. No bit signal is used to signal the end of data reception and tells the transmitter that it should move to stage 3. This signal comes on when the number of received bits equal to 18. Next is the transmitter registers. The TS FSM register stores the current state of the transmitter. The send OK register stores whether transmission is complete or not. It comes on whenever the transmission is in stage 3, that is the final state. Data register stores the data to be transmitted. The TS bit count register stores the number of transmitted bits. It counts them and stores them. The TS busy register is used to set the transmission line high whenever it's idle until it's ready to transmit data. This signal is inverted and used with an OR gate on the TS bit. So whenever it's high, TS bit is allowed to pass data, and whenever it is low, the TS bit is high or idle. Next is the transmitter state machine. State 0, state 1, state 2, and state 3. They can be represented here with a multiplexer. State 0 is the idle state. No transmission occurs here. If the ready to send signal is on, the transmitter resets the data register, TS bit count register, and sets the TS busy register high and moves to stage 2. Stage 2 and stage 3 are identical. Bit transfer occurs here. The data to be sent consists of a 0 start bit, a 16-bit data to be transmitted, a parity bit, and finally the stop bit or a high or 1. The TS bit count register starts counting at these stages using an adder here. Whenever the TS bit count register equals 19 in decimal and 12 in hexadecimal, the no bit signal is high and the TX FSM moves to stage 3 to mark the end of data transmission. At this stage, the send OK signal is set also to mark that transmission has ended. If the stop signal is on, the process ends at stage 3, else if it's 0, the transmitter goes back to 0 and starts transmission afresh. Finally, the TS busy register is set low and the TS bit line goes back to high or idle. So these are the logics inside the transmitter circuit. Leave your questions in the review section. In the next course, I will answer them and will continue again. Check out projectfpga.com for upcoming courses. I'll be remaking all tutorials to UDEMY standard. Please support my course by leaving a kind review. It will get better with time. Thank you.